This is a good example of a question that requires a little bit of planning before you start. It's worth 4 marks and there's a reasonable amount of blank space around the outside here. So let's have a think about some of the key ideas before we actually start getting stuck into this question. So it says a student wanted to determine the density of a small piece of rock. So the density is important there, and it's a small piece of rock which gives us a clue as to the method. Describe how the student could measure the volume of the piece of rock. So we're just starting with the volume to start with. Now, because this is an irregular object, it means we can't just measure the dimensions of it and multiply those up to give us the volume. So we're going to need to think of something different. So maybe you've come across something called a Eureka can. So that should then spark off in your mind something, well, perhaps this looks like a can, and then there's a spout on the side, and that had some water in it, which was to a certain level, and then you put your object in it and collected that, or maybe you collected it straight into a measuring cylinder, and when the object went in it, it was some irregular shape and it displaced some water, and the volume of that was equal to the volume of the displaced water. Okay, so we've just got a few key ideas up here. It's only after the volume, and there are 4 marks there. So what can we do? Well, you've probably got everything you need to do there. So we could start by saying fill a Eureka can to the level of the spout. Place a measuring cylinder below the spout. Place the rock into the cylinder, nope, into the Eureka can, and allow the displaced water to flow into the measuring cylinder. The volume of the displaced water is equal to the volume of the rock.